in this video where we're looking at linear coordinate geometry, we want to do a review of gradient. This will include calculation of gradient but also looking at angle of slope. So gradient is a measure of slope. How steep is the line? Okay, it is technically the rate of change of y with respect to x, i.e. how does y change as x increases by 1? So for every 1 increase in x, what is the change in y? That's what gradient is telling us about. Okay. So for example, if we have a gradient of 2, that means that as x increases by 1, y increases by 2. So for every 1 step across, we go 2 steps up. Okay. If the gradient is negative 3, if the gradient is negative 3, this means that as x increases by 1, y decreases by 3. So for every 1 step across, we go 3 down when we have a gradient of negative 3. If the gradient is half, we can think about it in two ways. That is, for every 1 step across, we go half a step up. Okay. Or if we think about rise over run, gradient as being rise over run. So the 1 is the rise and the 2 is the run. Actually, that is for every 2 steps across, we go 1 step up. And that's where we were actually doing the same thing up here. A gradient of 2 is 2 over 1. So the rise is 2 for every run, every horizontal step of 1. Okay, the vertical change is 2 for every horizontal change of 1. Similarly with this one. Vertical change of negative 3, so down by 3 for every horizontal change of 1. So we can either think about it as 1 across half up, or we can think about it as 2 across for every 1 up. Note that a negative gradient means that the line slopes down as you move from left to right. I know that seems really obvious, but people get bogged down in rise over run and formulas and they lose track of the line's clearly sloping down and the gradient should therefore be negative. So gradient is change in y over change in x, and we frequently refer to that as rise over run, the vertical change over the horizontal change. Note that it doesn't matter which 2 points on a line you select to calculate the gradient. A feature of a straight line is that it has constant gradient. So the gradient is the same the whole way along the line. So any 2 points and you look at calculating rise over run and you should get exactly the same gradient. So here you can see in the green triangle I've chosen these 2 points and I get rise over run tells me the gradient is 3 over 2. In the red triangle I've picked this point and I get rise of 6 and a run of 4. Gradient is 6 over 4, which simplifies to 3 over 2. In the purple triangle I've picked this point and this point. Rise is 9 and run is 6. Rise over run 9 over 6 also simplifies to 3 over 2. So it doesn't matter which 2 points you choose if you're trying to calculate the gradient of a line. Any 2 points, so pick points that are, don't try and guesstimate what the coordinates of that point is. Pick points that are actually at a nice clear point. 3 over 2, okay, and away you go. Alright, so in general, the gradient of the line that joins the points A with coordinates x1, y1 and B with coordinates x2, y2 is given by rise over run, which is the change in the y values over the change in the x values. What's really important if you're going to use this formula is that it doesn't matter which y coordinate, it would be exactly the same. You could actually also have y1 minus y2 over x1 minus x2. Wouldn't matter. People get bogged down in, which point is x2 and which point is x1. Doesn't matter. You just arbitrarily label, think about them as being, that point is point 2 and that point is point 1. The key thing is that the values have to be paired up. Whichever way round you do it, okay, these 2 values need to be from the same coordinate and these 2 values need to be from the same coordinate. Otherwise you'll get the negative wrong, okay? And again, that comes back to you then adding an extra layer of does my answer make sense? If you've used this formula to calculate gradient and you've ended up with a positive gradient where clearly the line slopes down, you've probably jumbled your numbers around. Okay, if we're thinking about horizontal and vertical lines, so a horizontal line, if we think about gradient as being rise over run, a horizontal line doesn't have any rise. There's no change in the y values at all. It only changes horizontally. So if we pick any 2 points, it doesn't matter which 2 points. Again, you get the same result, but if I match what I've got, I pick these 2 points here, there is 0 rise between those 2 points, and there's a run of 2. If I pick these 2 points, it'd be a run of 3. Wouldn't matter. The point is you've got 0 divided by something. 0 divided by something is 0. 0 divided by 2 is 0. So a horizontal line has a gradient of 0. A vertical line, however, if you think about rise over run, if you pick 2 points on here, okay, again, there's plenty of rise. We've arbitrarily chosen a rise of 2, but you could pick any other points and have a rise of 10, it wouldn't matter. Plenty of rise, but absolutely no run. So the problem here is that we're dividing by 0 because there's no horizontal change, and so the gradient, therefore, it's impossible to divide by 0, so the gradient of a vertical line, therefore, is undefined. If two lines are parallel, they have the same gradient. Gradient 1 is equal to gradient 2. Lines that are perpendicular are at right angles to each other, and the product of the gradients of two perpendicular lines is -1. So if you've got, two parallel lines here, gradient 1, gradient 2, they have the same gradient. Perpendicular lines at right angles to each other, gradient 1 and gradient 2, if you multiply those gradients together, they're going to give you -1. However, more commonly, we think about that when we're trying to calculate perpendicular gradients, we sort of think about that relationship rearranged. So if I were to divide both sides by one of those gradients, what we see is that one of the gradients is equal to the negative reciprocal of the other gradient. So reciprocal is b over a, is when we flip the fraction. Okay, so the negative reciprocal of the gradient gives the perpendicular gradient. So if this gradient was 3, this gradient would be -1/3. The reciprocal of 3, which is 3 over 1, is 1 over 3. If this gradient was 2/5, the negative reciprocal would be -5 on 2. Okay, if we knew this gradient is -7, the negative reciprocal of that is +1 over 7. Okay. Alright, let's do a couple of examples. Find the gradient of a straight line that passes through the points that we've got listed there. Okay, so the gradient, lowercase m, we commonly use for gradient. It's going to be the change in the y values over the change in the x values. I'm going to go with -6a minus 4a over. Now, because I used -6a first, I must use 2a first on the bottom. 2a minus -a. Let's tidy that up. So that's -10a on the numerator. 2a minus -a is 2a plus a, so that's 3a on the denominator. The a's will cancel down. Dividing the top and the bottom of the fraction by a just leaves us with -10/3. Example 2, a line has a gradient of -4 and passes through the points 5, 8 and -1a. Find the value of a. Okay, so we know that the gradient is going to be change in the y values, a minus 8. It's always easier to set it up with your unknown thing first. It's going to be a more complicated equation to solve if I have the a as being subtracted. So just making decisions that make the subsequent algebra easier for you. A minus 8 over -1 minus 5, and that gradient we know is equal to -4. And so now here is an equation that we can solve to find a. Let's just tidy things up a bit. We've got a minus 8 over -6 equals -4. Let's multiply both sides by -6. It's positive 24. And let's add 8, which gives us 24, 32. So a must be 32. Okay. Example 3. Line A has a gradient of 5. Line B has a gradient of b. If line A is perpendicular to line B, find B. Okay, so we know that gradient of line A, actually let's do it the other way around, gradient of line B is going to be the negative reciprocal of the gradient of line A, and so that means the gradient of line B, which is called B, sorry, they should be capital those. So the gradient of line B is called B, and it is equal to the negative reciprocal of the gradient of line A. Okay, example 4, line A has a gradient of -3/5. Line B has a gradient of B. If line A is perpendicular to line B, find B. Okay, so again, same idea. Gradient of line B is equal to the negative reciprocal of the gradient of line A. Okay, which means the gradient of line B is called B, and the negative reciprocal of -3/5, if you really want to probably write the answer straight down, but the negatives will cancel each other out. we essentially have 1 divided by 3/5 there, which is 1 times 5/3. And so it is 5/3. Again, just immediately taking the negative reciprocal of that. Really, you shouldn't need to do all of that calculation. But it does still fit this formula. That's what's happening. Okay, the last thing I want to look at in the context of gradient is the angle of slope. This is actually something that we don't really talk much about before Year 11 methods. And it just sort of magically appears amidst the coordinate geometry here, and we probably should introduce it a little earlier. I would have once said to you it doesn't really come up very often, but I have noticed it coming up more and more often in the context of various Year 12 problems over the last couple of years, so it certainly is something to be aware of. But really, again, it's not about remembering an ugly formula, it's about thinking about what's actually happening here. So this is about thinking about trigonometry. So when we study trigonometry and right-angled triangles, we know that tan of the angle in a right-angled triangle is equal to the opposite side length over the adjacent side length. And so when we apply this, so I've got my same diagram here, 2 points, A and B. What we're interested in here with the angle of slope is this angle in here, okay? Usually the angle that we're interested in is the angle that the line makes with the positive x-axis, okay? So the line in the positive x-axis, we're usually talking about that angle in there. It's not always an acute angle. If you've got a line with negative gradient, it will be an obtuse angle. That might be what you're interested in, but you could also be interested in this, so you need to be a bit careful about what the question's asking you for. Okay, so tan of theta is opposite over adjacent, and if we think about this triangle that I've got happening here, opposite over adjacent, well that's the opposite, which is y2 minus y1, and that's the adjacent, which is x2 minus x1. So tan of theta is y2 minus y1 over x2 minus x1, which is rise over run, which is the same as gradient. So tan of theta equals the gradient. So that's really the key thing that's going to allow us to find the angle of slope. So that means in solving that equation, theta therefore is the inverse tan of the gradient. Now, there's some slight things to be careful about here if the gradient is negative, and sometimes you might be better to just draw yourself a quick diagram, particularly if you've got negative gradient, to be clear about whether you're trying to work out this angle or this angle. And maybe instead of using the gradient, you then just, once you've got your diagram drawn, you literally just use, you know, trigonometry in a right angle triangle to work out the angle that you're after, okay, and then work from there. There was certainly a problem in, I'm trying to remember, it was an exam paper that I did towards the end of last year. I don't think it was the actual VCA paper, but maybe it was one of the trial papers, which did require you to use this formula, but you got yourself into a bit of a mess if you just immediately thought about this, whereas if you actually looked at a diagram and went, oh okay, well here's a right angle triangle that I can use trig in, and just did it by looking at the triangle and thinking about that as being the opposite and that as being the adjacent, it sort of turned out a bit neater. So, you know, don't be afraid to draw diagrams and see what it is that's happening. Okay, so let's have a think about this. We'll have a look at what happens when we just use the rule with a negative gradient in the examples here. The other thing is to make sure that your CAS is in degree mode. When you're asked for the angle of slope, it's usually asking you for that angle in degrees to 1 decimal place, whatever it might be. And in fact, we probably need some clarification here. In each of the following, find the value of theta, let's say, correct to 1 decimal place where necessary. If they're exact, that's fine. Okay, so what we know here is that the gradient is 2. Okay, we can see that there in the equation. Okay, and so that means that tan of theta is going to be equal to 2. And so theta is going to be inverse tan of 2. And when we type that in our calculator, my calculator is in radian mode. If you've got a newer calculator, now when you just click on this, you can change it without having to do anything. If you've got an older calculator, you'll need to actually click on the battery icon, go to document settings, and change the angle mode to degree. Okay, so make sure you're in the right mode. If you've got a really old calculator, your calculator won't even tell you what mode you're in up there. I would suggest trying to update your software if that's where you're at, or maybe get a new CAS. If you're just starting out in Methods 1, 2, you've got 2 really big years ahead where you want reliable technology. I know it's a big expense, but think about that spent over those 2 years. You know, it's not too bad. Alright, so we need inverse tan, so trig button, inverse tan of 2, control enter to get a decimal value, we're in degrees, so correct to 1 decimal place, it is 63.4 degrees. And again, a little bit of, does my answer make sense? If you've got a line that for every one step across, you go 2 steps up, which is what a gradient of 2 means, does it make sense that that angle would be about 63 degrees? Yes, it does. Alright, so here in this one, we've got a negative gradient, okay? So the gradient is -3, and this is the angle up here that we're after, okay? So what we need to be a bit careful about here, I'm not going to say that it's tan of theta equals -3 because it won't be giving me theta. So tan of some other angle, alpha, is equal to -3. Alpha, therefore, is inverse tan of -3. And if you do inverse tan of -3, Control Enter, you get -71.6 degrees. Okay, so obviously the answer isn't negative, the angle of slope's not negative, but actually you can think about that as indicating to you, what that's actually giving you is it's giving you the angle under the x-axis. Under the x-axis by -71.6 degrees. So therefore, that's alpha there. Okay, but it's not also because an angle isn't negative. But you can think about the negative as sort of telling you I'm an angle that's under the x-axis. So because the CAS will always give you an acute angle, it's not going to give you this one. It's got a choice between giving you 2 solutions here, this one or this one. It'll always give you the acute one. But you can think about the negative on the acute angle as telling you that it's below that's an angle that's below the x-axis. So if this is the one we actually want, then we need to sort of think that through. Therefore, theta is going to be 180 minus 71.6. Because it's already a negative in my CAS here, I just add 180 to that answer. That's going to get me what I want. So that's 108.4 degrees. Okay, so just thinking a bit carefully. So again, you might prefer to just sort of think about, alright, well, if I just draw, an arbitrary triangle with a gradient of -3, that's 3 and that's 1. Use that to work out that angle in there. Inverse tan of 3. Sorry, I always do that. Inverse tan of 3 is 71.56. That's the angle here in this triangle. And so therefore subtracting that from 180 gives me this angle out here. Okay. So again, keeping an eye on what you're doing. Don't be afraid to draw a diagram rather than just thinking blindly about rules and formulas. Okay, exercise 2b to do with just some revision of gradient and also some practice of this angle of slope.